Okay. Sometimes we need to use identities to solve these trig equations. Okay, so in this case, they tell us use identities to solve the trig equation over the interval, and they give us this equation. All right, so the first thing I notice is there's a lot of different like trig things here going on. There's a cosine of 2x, a sine of x, a sine of 2x. And then I think, wait a minute, I know some identities that have stuff that looks like that. I have cosines multiplied together and sines multiplied together. Let's see, let's look at our sum and difference formulas. Here's cosines multiplied together minus sines. Oh, here's cosines multiplied together plus sines multiplied together. So this actually looks like a difference formula if my alpha is x and my cosine is 2x, or my beta is 2x, right? My cosine is x and my beta is 2x. Yeah, this would work. So I can actually use this trig identity to simplify this to be cosine of x minus 2x equals square root of 3 over 2. Is this a contrived problem? Yes, it is, to make it so that I could use one of these sum and difference formulas. But sometimes we have contrived problems in math classes. So the trick here is to like take a deep breath and say, have I seen this somewhere before? And by this point, you have been using all of this formula sheet quite a bit. And there's a hint, use identities to solve it, right? So anyway, not the most straightforward thing, but once you see it, all right, cool, now I'm in business, right? I can write this as cosine of minus x equals square root of 3 over 2. I don't know why I read a negative there. Just ignore that. Cosine of negative x. Well, cosine is even, so this is the same as cosine of x equals square root of 3 over 2. Do I know this? I do from my formula sheet, and that's pi 6. So that's going to give me this answer right here. So x equals pi 6. And I also need my answer over here, which is going to be 2 pi minus pi 6. So that's going to be 11 pi over 6. Ta-da. Okay. What about, I need more scratch paper. Solve this exactly using a double angle formula. Cosine of 2 theta equals cosine of theta. So they're telling me use a double angle formula. So cosine of 2 theta. So this is one where I have options. Which of these am I going to want to use? This one, or this one? Well, I'm going to want to keep everything in terms of theta. So I'm going to use, or not theta, cosine, right? Since cosine is over here, I'm going to use this intermediate one, which is kind of bad news because, so I'm going to say 2 cosine theta minus 1 equals cosine theta. And that's too bad because I'm going to have a quadratic equation, but I don't think I can avoid it. It's certainly better than having like cosines and sines in the same problem, which really you can't solve without using like a graphing calculator or something, like just to look at the graph. So our goal is always to have everything in terms of just one trig function. Okay, we can't deal with like sines and cosines in the same problem. So I have to use the one that just has cosines. All right, but as we know, we can solve quadratics even if we don't like to. So let's put everything on one side of the equation. And here we go. I'm looking for things that multiply to -2 and add to -1. So -2 cosine theta plus cosine theta. All right, I'm using grouping. And so now I'm going to factor out a 2 cosine theta, and I'm left with cosine theta minus 1 plus cosine theta minus 1. Okay, so I'm going to factor out a cosine theta minus 1, and I have 2 cosine theta plus 1. Okay, cool. So now I'm going to split these up, set that equal to 0, so I get 1. And if I set this equal to 0, I'm going to get -1/2, right? And They don't give us a restricted domain here, so they just want all the values. So let's see, cosine of theta equals 1 at 0, and at 2 pi, so it's going to be plus or minus 2 pi times k. And where's cosine theta equal to negative 1/2? Well, from our table, we get that that's at 2 pi thirds. And this one over here, let's see if we have symmetry, right? That's going to be 1/3, so this is another third. So that's going to be at 4 pi thirds. And then we can add 2 pi plus or minus 2 pi k to both of those. So I'm going to get 3 solutions plus or minus, 2 pi k, infinite solutions. Okay, what about this one? Solve it exactly. So they don't tell us which identity to use, but they say 3 cosine theta plus 3 equals 2 sine squared theta. All right, so we have cosines and sines in the same equation. Not going to be able to do that. So let's look at the sine squared identity, the power reducing one. Yeah, we could use this. Wait, is that what they do? No, they don't. So we don't have, this is clever. So looking at that power reducing one, if we do that, we could put it in terms of cosine, but it's going to be in terms of cosine of 2 theta, which seems like a problem. We want to have things in the same angle inside our argument. But we could just use the quadratic formula. Don't have to be all fancy with our sheet. We could use, or not the quadratic formula, the Pythagorean identity. We could use the Pythagorean identity. So we could write, instead of sine squared theta, we could write that as 1 minus cosine squared theta, right? Yes, we could. So sine squared we wrote as that. So there we go. Let's bring everything to one side. So we can write this as 2 cosine squared theta plus 3 cosine theta plus 1 equals 0, right? If we bring the 2 over as well. All right, so we're looking for things that multiply to 2, add to 3. How about 2 and 1? So I split this one into 2 terms. I'm going to factor out a 2 cosine theta. And I'm left with cosine theta plus 1 plus cosine theta plus 1. I'm going to factor this out. And I'm left with 2 cosine theta plus 1. All right, so I've got 2 equations. Cosine theta equals negative 1. And if I set this equal to 0 and solve for cosine theta equals negative 1/2. And they want us to solve it just for 0 to 2 pi. Okay? So from 0 to 2 pi, cosine theta equals negative 1 at pi. And cosine theta equals negative 1/2. Well, let's see. From our table, we can get this solution. Cosine theta equals negative 1/2 at 2 pi thirds. Yep, 2 pi thirds. And this is 1/3. Pi plus 1/3 is going to be 4 pi thirds. So again, really helpful on these to draw a little sketch so that you have a clue about how many solutions you're expecting, right? So you don't forget the second solution. Right, so here are our 3 solutions to that. All right, so using identities, not so different, right? The main thing we're going to use them for is going from sine, if we have an equation with sines and cosines, to use an identity to just have just sines or just cosines in a problem.